All right, so finally got my computer figured out a little bit there. Don't know what happened. All right. So what were we doing? We've managed to find out that negative 1/3 was a 0, which means that this factors into, still bringing down that x minus 2. Now this factors into x plus my new factor, the 1/3, times, and my leftover factor, let's see, that's going to be 3x squared plus 0x minus 6. All right, we could go ahead and try to find the possible zeros for this new factor here, or we could try and ask ourselves, can I factor this? Yeah, I know how to factor that. That's going to be x minus 2, x plus 1/3. I can factor out the 3, and I'll be left with x squared minus 2. And to make things look nicer, I'll just bring that 3 out front. And there we go. That is my factored p of x. Lastly, we have to list the real zeros, so part C. The real zeros, that we get from here. So it's going to be x equals 2, x equals negative third, and x equals, let's see, how would I figure out what this is as a 0? So x squared minus 2 equal to 0, add 2 to both sides. Take the square root of both sides because I'm solving for x. X equals plus or minus the square root of 2. All right, there we go. So that's a real number. All right, so this, though, is not necessarily, it is a real 0. Okay, so we'll include it in the real zeros. All right, square root of 2. So the next part, narrowing down the choices. Okay, so that's what we want to do, is see if we can narrow down the choices, and I'll show you why. Okay, because notice before, when we were just looking at the factors of 2 and 3, we still ended up with 8 possible zeros. That's a lot of numbers to do synthetic long division on. And that just came from the numbers like 2 and 3. What if our numbers end up way bigger? So let's take a look at what that looks like. So we're going to list the possible rational zeros of this polynomial. So here's my L value is 12. My C value is also 12. Now those numbers are big. All right, so C divided by L, that's going to be 12 divided by, or factors of 12. Factors of 12 divided by factors of 12. And what are the factors of 12? That's going to be 1, 2, 3, 4, 6, and 12? Yeah, those are the factors of 12. 1, 2, 3, 4, 6, and 12. Oh, that's a lot of factors to be looking through. All right, but let's go ahead and do this. So, possible zeros. Let's start with 1. So plus or minus 1, 2 over 1 is 2, 3 over 1 is 3, 4 over 1 is 4. In fact, I can just write them all down because I know they're all going to be over 1. Well, that was when we looked at 1. Let's look at 2. So 2 over 1, that's going to be half. 2 over 2 will be 1. 3 over 2, well, that's 3 over 2. 4 over 2 is 2, which I already wrote down. 6 over 2 is 3, which I already wrote down. And then 12 over 2 is 6, which I already wrote down. All right, so we've done the 2's. Let's look at 3. 1 over 3. I don't have that yet. 2 over 3. Do I have that yet? No. 3 over 3. That's 1. I have that. How about 4 over 3? No, I don't have that yet. Oh my gosh, this is a lot. Okay. 6 over 3? That's 2. I have that. Right there. 12 over 3. That's 4. I already have that. Okay, so we're done with 3's. Go ahead and see if you can write down the numbers for the denominators of 4, 6, and 12, and check it back in with me in a few seconds. All right, so let's see. Okay, next one is 1 over 4. And then 2 over 4, that's a half. I already have that. 3 over 4, I don't have that yet. 4 over 4, that's 1, I have that. 6 over 4, that's 3 over 2. I already have that. 12 over 4, that's going to be 3, which I already have right there. Okay, 4s are done. Let's look at the 6. 1 over 6, I don't have that yet. 2 over 6, that's 1/3, which I do have. 3 over 6, that's a half, which I already have right there. Did I already say 4 over 6? Yeah, okay. 6 over 6 is 1, which I already have right there. 12 over 6 is 2, which I already have. All right, lastly, 12. 1 over 2. Sorry, 1 over 12, excuse me. 2 over 12, that's going to be a 6, which I already have right there. 3 over 12 is going to be a 4th, which I already have. 4 over 12 is going to be a 3rd, which I already have. 6 over 12 is going to be a half, which I already have. And 12 over 12 is going to be a 1. Alrighty daddy, so here are all my possible zeros. That is a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. But that's just the positives. Adding in the negatives, what is that, 32? I do not want to sit here all day long and do synthetic long division on these. Okay, so we're going to look at a way of narrowing down our choices, okay? Because if we can do that, that would be a real blessing. All right, so let's take a look at what is called the upper and lower bound theorem. So we're supposing C is a rational zero of f of x. Okay, so C meaning one of these possible zeros, all right? Or, sorry, one of the actual rational zeros. So when C is an upper bound if when C is synthetically divided into f of x, the numbers in the final line of the division have the same sign. So what do I mean? Let me pull in one of my examples from our long division. See these guys in the bottom here? This is what I'm talking about. Okay, notice these. That's a 3, that's a negative, that's a negative, that's... Okay, so think about 0, 0, we can call it positive or negative depending on what we want. 0 is nice. So these do not all have the same signs. Some are positive and some are negative. Okay, so if the number we're dividing into is a positive and all of the signs on the bottom are positive, this is saying, or if they're all negative too, the numbers in the final line of the division, this is an upper bound, okay? So the number we're dividing by is an upper bound if they all have the same sign on the bottom, either all negative or all positive, okay? C is a lower bound if, when we divide C into f of x, the numbers have alternating signs. So what does that mean? Well, alternating signs would be something, for example, so remember we're talking about a lower bound, so a negative. Oh, I forgot to write this down. This should be C is less than 0, and this is C is greater than 0. Sorry, write that in. Okay, so we're dividing by C, less than 0. We do some long division, blah, blah, and we end up with something that's positive, something that's negative, and something that's positive, and negative, and positive. Okay, see this alternating signs? That means it would be a lower bound. Okay? Or we could have another option. You do the long division, blah, blah, and you end up with negative, positive, negative, positive, negative. This is still alternating signs. It doesn't matter if you started with a positive or you start with a negative sign. As long as it's alternating, this is a lower bound. And if you end up with a 0, somewhere where you're adding or subtracting, somewhere where you're adding. As I said before, 0, it could be a positive or negative depending on the needs in the situation. If, in order to make this pattern work, you need it to be a negative, you can consider 0 a negative. Or if this was a 0 and you needed it to be a positive, you could just say, it's positive, okay? So 0 can fit the situation if needed, or as needed. Okay, so this is going to be a way of not having to check every single possible 0, okay, because as you noticed in our last example, you can end up with a bajillion possible zeros. So what we're going to do is see if we can find an upper bound and a lower bound. How does that work? For example, if I found out through all of my testing that 6 was an upper bound, that means I wouldn't even have to check 12. Because I know 6 is the highest possible number there, it's an upper bound, 12 wouldn't work. Or if I found out that 3 was if 3 was the upper bound, then I wouldn't even need to check 4 and 6, because 3 is my upper bound. Or if I was looking at a lower bound and I found out that 3 was my lower bound, then I wouldn't have to check 2 or 1 to see if they were actually zeros. Okay, so that's the nice thing about the upper and lower bounds, is it tells us which numbers I actually have to check. So I don't have to actually end up checking all of them. So let's go ahead with A, possible rational zeros. Okay, so we've been doing this before. Go ahead and see if you can write out all the possible rational zeros. All right, what would those be? Okay, so possible zeros. Plus or minus. Okay, so we have 8 possible zeros. And let's go ahead and test them. So what I'm going to do is I'm just going to test, I'm going to write them all out as if I was going to test all of them and then see if we actually have to end up testing all of them. Okay, so let me set this up so I could pretend we were going to test all of them, which we actually don't want to have to do. Whiteout work, okay. Okay, so just take a second, set it up so you can, we're testing them all synthetically to see if they are a zero. Hopefully we won't have to test them all. All right. Okay, so let's see, our polynomial is going to be 1, 1, negative 7, negative 1, 6. Let's write that down. And I'm just going to go ahead and fill those all. Ooh, that looks like an 11. No, not good. Okay. You normally wouldn't write them all out like this, but I'm just going to go ahead and do that for this. Ooh, I have no idea what happened right there. So hopefully I don't actually have to end up testing all of these. Hopefully I will find an upper bound or a lower bound and go with that. Let's go ahead and start with 1. Okay, you can go ahead and try these by yourself and check in with me in a second. So multiplying that out, that'll be 1, adding is 2, multiplying 2, adding negative 5, multiplying negative 5, adding negative 6, multiplying 6. Aha, look, I found a 0. So this is a 0. Actually, this is a 0. The 0 is just, it is a 0 technically. Okay. Well, that worked. It actually wasn't technically an upper or lower bound I was trying to find, but it is a 0 of our polynomial. Okay, so that's good. We found a 0. Let's see. Let's test 2. Okay, 1, that's going to be 2. 3, it's going to be 6. Negative 1, that's going to be negative 2. That'll be negative 3. Negative 6. Oh, what do you know? There's another 0. All right, so notice this was a positive, but the signs weren't all positive, so that's not considered an upper bound. This is a positive, but the signs are not all positive, so this is also not an upper bound. Let's check the next one to see if we find an upper bound. So that's going to be 1 multiplying 3, 4 multiplying 12, 5. 3 times 5 is 15. Adding that, that's going to be 14. 13 times 14 is going to be 42. Adding that, 48. Okay, well, this was not a 0. But notice, here's our positive c value. And what do you notice about all the signs on these? These all have positive signs. So this, my friends, this is an upper bound. Our 3 is an upper bound. which means I know I don't have to check 6 to see if it gives us a 0. It's not going to happen. Okay, so 3 is an upper bound. I don't need to check any numbers higher than 3. Awesome. Save me one thing to check. Let's go ahead and check -1. All right, bringing down the 1, that's going to be -1. That'll be 0, 0, -7. It's going to be 7, 6, -6. That is a 0. All right, let's see. Well, this is a 0. But it's not a lower bound because it's not alternating signs. It's positive. That could be a negative or positive, but then that's a negative. So if I did this a negative, that would be positive, negative, negative. If I did this a positive, that would be positive, positive, negative. So that's not alternating. Okay, but that's a 0. Let's try the next one. Bring down that 1, multiplying, -2, adding, -1, multiplying, 2, adding, 5, -5, sorry, multiplying, 10, adding, 9, multiplying, -18. What's -6? Which, let's see. The signs are not alternating. This is still a negative, but these signs are not alternating, so that's not a lower bound. Shucks. Okay, so that's technically nothing. Sorry, -2, you are nothing. All right, let's bring this down. So 1, multiplying, -3. It's going to be -2, multiplying 6, -1, multiplying 3, adding 2, multiplying -6, adding, 0. So we found a 0. Okay. Let's go ahead and check the last one because we haven't found our lower bound yet, and we need to find a lower bound. So 6 had better be, -6 had better be our lower bound. Or we've done something wrong. All right, 1, -6, adding that, sorry, -5, multiplying 30, adding 23, multiplying, it's going to be -138, that's going to be -139, multiplying, that's going to be some huge number, but I know it's going to end up being a positive huge number, which is a positive. And notice, look at the signs. Here's my negative. Let's look at the signs here. Are they alternating? That's a positive, that's a negative, 23 is a positive, -139 is a negative, and my last number I knew was going to be a positive. Those signs are alternating, which means -6 is a lower bound. Okay, so I'm going to write that out. Let's see, 3 is an upper bound, and -6 is a lower bound. Sadly, we had to go all the way to -6 to find our lower bound there, but if we'd had a number like -12, we would know we wouldn't have to check it because that would be smaller than -6. Okay, so upper and lower bounds can help keep you from having to check all of your numbers. Sadly, in this problem, the only one we didn't have to check was 6, or at least the way I set this up. All right, and then written homework is the last thing for 3.4. If you have any questions on 3.4, please let me know. Give me an email.